We're going to find the radius and interval of convergence for this series. To find the radius and interval of convergence, we should always begin with identifying the center, and the center for this series is equal to 0. So we can say A is equal to 0. Because remember, whenever you have a power series, you have a power series in the form of x minus a to the nth power. And here, because you just have x to the nth, then that means a is equal to 0. Moving on to the radius and the interval of convergence. We're going to do that by taking the limit as n approaches infinity of a sub n plus 1 over a sub n. And remember that when that limit is less than 1, then the series will converge. This is the ratio test. So applying the ratio test to our problem gives us the following. The limit as n approaches infinity of n plus 1 factorial x to the n plus 1 over 1 times 3 times 5 all the way to 2n minus 1 and 2n plus 1. Where do we get this 2n plus 1? You see, what we're doing is we're letting n be equal to n plus 1, right? We're doing the a sub n plus 1. So this will be 2 times n plus 1 minus 1, which gives us a 2n plus 2 minus 1, and that gives us a 2n plus 1. So this will go all the way to 2n plus 1. And the odd number before 2n plus 1 is at 2n minus 1. We're going to multiply times the reciprocal, and the reciprocal, let's see here, it's going to be equal to 1 times 3 times 5 all the way to 2n minus 1 over n factorial times x to the nth. All right, so this here gives us the limit as n approaches infinity. I'm going to show the work for those of us that need to see the work. But you can skip a couple of seconds ahead if you don't need to see the work. So n plus 1 factorial is n plus 1 times n factorial. X to the n plus 1 is x to the nth times x. And then I'm going to simplify 1 times 3 times 5 all the way to 2n minus 1. And when we do that, the denominator now becomes the 2n plus 1 n factorial times x to the nth. So we can simplify n factorial with n factorial, x to the nth with x to the nth. And this gives us the limit as n approaches infinity of n plus 1 over 2n plus 1 times your x. But x is a constant. So since x is a constant, when you're taking a limit with respect to n, then I'm going to write that constant in the front. So this becomes the absolute value of x times whatever this limit is. And that limit is nothing other than 1/2. Now, remember, we are applying the ratio test because we want to know for what values of x does this series converge. So the series will converge when this, which is the absolute value of x over 2, is less than 1. So we can say convergent when it's less than 1. That is by the ratio test. All right, so now since we have the absolute value of x over 2 less than 1, we can solve for that absolute value inequality and say that the absolute value of x is less than 2. Remember, in general, we would have it in the form of x minus a is less than r. When you have it in the form of x minus a in absolute value less than r, you can clearly identify what a is, which is 0, and we talked about that earlier, and r is equal to 2. So the radius of convergence is 2. Now to find the interval of convergence, we just solve that absolute value inequality and say that x is between -2 and 2. But remember, we must check the endpoints. What happens if x is equal to -2? If x is equal to -2, let's go back up here. If x is equal to -2, we're going to have sigma as n goes from 1 to infinity, n factorial, -2 to the n, over 1 times 3 times 5, all the way to 2n minus 1. And now we got to determine if this series is convergent or divergent. So this is very similar to what we just did. The only difference is that we have, instead of x, we have a -2 to the n. We can take the limit as n is approaching infinity of n factorial. In absolute value, you're going to have 2 to the n over 1 times 3 times 5 times all the way to 2n minus 1. And when you take the limit, that limit is going to go towards infinity. So what does that say? That says that our series, which is this one, is divergent by the test for divergence. And then if you let x be equal to 2, then now we have the exact same thing. Let me just copy it again. So if x is equal to 2, then this is a positive 2 to the nth power. And then when you take the limit of your c sub n, that is still going to infinity. So we can say that the series will also diverge by the test for divergence. It doesn't always have to be a test for divergence. You can use any of the other tests when you're checking the endpoints, okay? So it just happens to be that the two examples I did use the test for divergence. And then the last thing I want to tell you is, remember, the problem was asking for the radius of convergence, which is 2, and the interval of convergence, which is from -2 to 2. So interval of convergence from -2 to 2, and the radius of convergence is 2. So when you center your power series at 0, that power series will converge. That power series, so the sum will exist for some numbers, or actually for all of the numbers, between -2 and 2. So that's what this example is doing, or that's what the interval of convergence is telling us.